Ninth class, this lecture is about chemical species. As we all know that matter is made up of tiny particles called atoms. These atoms may or may not exist independently. They form molecules or ions and constitute various substances. Here we have shown the structure of an atom in two ways. You can see that there is a central portion in an atom which is called the nucleus, and it contains protons and neutrons in it. And the circular pathways, which are known as orbits, and they contains electrons in them. Proton in the nucleus carry positive charge on them, and the electron in the orbits have negative charge on them. They carry equal but opposite charges. However, the number of protons and electrons in an atom are the same. Thus, an atom is electrically neutral. Here, one of the atom is of cobalt, and you can see that 27 is the atomic number of cobalt, and it is having the same number of protons, that is 27, as well as the same number of electrons in the orbits, which is also 27. So they will cancel the effect of each other, and electrically this cobalt atom is a neutral atom. However, it is possible for an atom in different circumstances to either gain or lose electrons. In both the cases, the balance and the positive and the negative charges can be disturbed, as the number of electrons will change. As a result, an atom will either gain positive charge or negative charge on it and no longer be known as an atom, but it will be known as an ion. If an atom will lose electron, it will get positive charge on it and will be known as a cation. If an atom will gain electron, it will be negatively charged and known as an anion. In these figures, the cation and anion formation has been given. Now, in cation formation, you can see that the number of protons in this atom are 3, as well as the number of electrons. The neutral atom is having 3 protons in its nucleus and 3 electrons in its orbit. But after the loss of one electron from the orbit, you can see that the number of protons remains the same, that is 3, but the number of electrons are not 3 anymore, but they have become 2. So you can see that the imbalance is produced between the number of protons and the number of electrons, and the resultant ion gets plus 1 charge on it, as it is having one positive charge greater than the negative charge. In the formation of an anion, again you can see that there are 3 protons and 3 electrons in the neutral atom, but after gaining one electron, its electrical balance has been changed. The number of protons are still 3, but the number of electrons has been increased by 1. So this ion will get minus 1 charge on it, and hence this anion will be formed. Now this figure shows the formation of sodium ion. You can see that the neutral atom of sodium is having 11 proton in its nucleus, and there are 11 electron in these orbits which are present around the nucleus. In the cation formation process, sodium will lose one electron from its outermost shell. In this figure, the second figure for sodium is of sodium ion and not of the sodium atom. As you can see that the outermost shell is now empty because it has lost its one electron, and as a result of it, the number of proton remained the same, that is 11, but the number of electrons has become 10. So there is an imbalance created between the electrical charges of protons and electrons, and now overall this atom will get plus 1 charge on it, and now this is no more known as a sodium atom, but now it is the sodium ion, which is a cation in fact. Now this is the example of fluoride ion formation, which is an anion, the negative ion. You can see that in the neutral atom, of fluorine, there are 9 protons in the nucleus and there are 9 electrons in the orbits, and there is one empty space where an electron can accommodate. So what happens that an electron from any other source will join this fluorine atom, and as a result of it you can see that the number of protons are still the same, 9, but the number of electron has been increased. Now there are total 10 electrons in its ionic state. Now you can see that there is a disturbance of electrical charges. The number of proton is 9, the number of electrons is 10, and as a result of it, this fluoride ion will get -1 charge on it. This is an anion of fluorine. After ions, the next chemical species which we are going to discuss are known as molecular ions. These molecular ions are formed when a molecule either gains or loses electrons, and as a result of it, it carries positive or negative charge on it. You should remember that molecular ions are not the same as the ions we have just studied, which are formed from atoms. These are formed from the molecules. Like here, you can see the examples of nitrogen molecule. In one example, the nitrogen molecule is having positive charge on it, and in the other one the nitrogen molecule is having negative charge on it. So these are the molecules which are not neutral anymore, and they are having positive or negative charges on them. uh, it is also important to remember that these molecular ions are not stable species. They are very short-lived species, and they produced and exist only under special circumstances, like at very high temperature. They are formed, and they exist only under that condition. Otherwise, when the normal temperature is attained, they will no longer remain in their charge form. After an ion and the molecular ion, the next chemical species which we are going to discuss is known as the free radical. Free radical is an atom which is having an unpaired electron, but it bears no electrical charge on it. Such as we are having the example of chlorine. In this above figure, you can see that there are 7 electrons in the outermost shell of chlorine, and out of these 7 electrons, 6 of them are paired. These paired electrons are known as lone pair of electrons, but one of the electron remain unpaired, and you can see that there is no electrical charge present on it, and then this is called the free radical of chlorine. How these free radicals are formed? These are formed by the cleavage of a molecule. Like in case of chlorine molecule, when ultraviolet radiations fall on chlorine molecules, the bond between the two chlorine atoms breaks down, and as a result of it, two chlorine free radicals are produced. Then the question arises, how can we differentiate between an ion and a free radical? Here we have given the differences between the ion and the free radicals with the example of chlorine, chloride ion and chlorine free radical. First, if you see the figure of chloride ion, you will see if you count the number of electrons in the outermost shell of chloride ion, you will see that these are the even number of electrons, and as a result of it, you can see that there is no unpaired electron present, and also the negative charge is present on this chloride ion. But in case of chlorine free radical, the next figure, you can see that there are 7 electrons in its outermost shell, the odd number of electrons, and one of the electron is unpaired, and as a whole, there is no charge present on this chlorine atom. This is neutral. So these are the differences between an ion and a free radical. The number of electrons, even and odd number of electrons, paired and unpaired electrons, and charged and neutral species. Class 9th. Now, as you know about the definition of ions and how they can be formed, you should know that there are certain type of compounds which are known as ionic compounds, and they are made up of ions and not of individual molecules. Ionic compounds basically consist of array of oppositely charged ions rather than molecules. So they are represented by formula units and not by their molecular formula. Here in this figure you can see the example of an ionic compound, which is sodium chloride. Sodium chloride is made up of sodium ion and chloride ion, and now you know that sodium ions are positively charged ions and chloride ions are negatively charged ions. Uh, all the sodium ions in this structure are surrounded by the negatively charged chloride ions, and the chloride ions are surrounded by positively charged sodium ions, because you know that opposite charges attract each other. So, as a result of it, a whole huge structure of sodium chloride is present, and it is not possible for us to separate an individual molecule from this whole structure. So, such type of structures which are ionic in nature, we represent them with the help of formula units. This figure tells you the difference between the formula unit and the molecule. Again, here the formula unit of sodium chloride has been given, and you can see that it is not possible for us to pick one sodium chloride molecule from this whole structure, because all the positively charged sodium ions are surrounded by all the negatively charged chloride ions around it, and the chloride ions are surrounded by sodium ions. So it is not possible to separate any two species from it as a molecule. And in the other figure you can see that there is an individual molecule made up of various different type of atoms. This is an organic molecule, but as a whole, this whole structure is an independent structure, and it is not the part of any big crystalline structure. So this is the molecule which is having the independent existence, separate existence, and the formula units are part of huge crystalline structure, and they cannot be separated. Our next topic is the representative particles, which can be atoms, molecules, or ions. Uh, The term representative particles refer to species present in a substituent. Like if we are having any element, like we are having copper, it is made up of atoms. It means the representative particles of copper are atoms. Whereas if we are having some compound like water, it is a compound. The representative particles of compounds are the molecules. So, water representative particles are the water molecule. And then there is sodium chloride, which is an ionic substance. And this, the representative particles of this ionic substance are the formula units of sodium chloride. In these figures, various representative particles have been shown. Like you can see the oxygen molecule, which is the representative particle of oxygen gas. Carbon dioxide molecule, it means that the molecule of carbon dioxide is the representative particle of this compound carbon dioxide. This figure present in the middle, that shows the representative particles of water, that is water molecules. And then this last figure shows the representative particle of helium gas, that is an atom. The representative particle of helium is an atom. So all these figures shows different type of representative particles, depending upon that either we are having elements, compounds, or ionic substances. The representative particles can be atoms, molecules, or formula units.